Welcome back to another episode of Science with Mr. Emond. Today we're going to be continuing our unit on enthalpy. We're going to be using knowledge that we've gained so far on Hess's law, on standard enthalpies of formation, and on enthalpy in general and the rules associated with working with it. And we're going to start to apply that to some problems that require a little bit of stoichiometry, like this one here. So in this problem, according to the reaction below, which is that hydrogen gas is mixing with iodine gas and is using or absorbing 52 kilojoules in the process, and it's going to create 2 moles of hydroiodic acid. How many kilojoules would be absorbed if 6 moles of iodine gas were reacted? Well, let's go ahead and give this a shot. So what do we know? We know that we have 6 moles of iodine gas. And we know that 52 kilojoules of energy are required for every, there's only 1 mole here, 1 mole of iodine gas. So 52 kilojoules of energy for every 1 mole. We can see that from our problem. Let's see what this is going to give us. Well, moles of iodine gas are going to cancel out. So what's left? Kilojoules. What's our problem asking for? How many moles of kilojoules? Or not how many? What's our problem asking for? How many kilojoules? And so what is this? Well, 6 times 52, if you look in the calculator, is 312 kilojoules. And that's it. That's what the problem is asking us. We're not done. We need to have the right number of significant figures here. So how many significant figures is in our 6 moles? That's just 1 significant figure. So this needs to be changed to 300 kilojoules. Let's move on. Okay, based on this equation, we have 2 moles of ammonia breaking down into nitrogen gas and 3 moles of hydrogen gas. And lucky us, they're giving us the change in enthalpy, which is positive 92.4 kilojoules, which means that this is an endothermic reaction, and therefore we know by default that this energy would be on this side of the equation. I'm not sure if that's going to be useful yet, because we should probably read the question. How much heat is absorbed? Okay, so it is on this side for sure, and we're wanting to know how much heat's absorbed when 68 grams of ammonia decomposes. Okay, so we have another clue here, which is that we are dealing primarily with ammonia. Let's go ahead and see if we can solve for this. What do we know? We know that we have 68.0 grams of NH3 to begin with. Well, when we're dealing with this delta H, what is it? It's actually kilojoules per mole, right? So we need to find moles. That's what we're looking for. So how do we get from grams to moles? Well, we use molar mass. Let's put our states of matter in here too. Okay. And what's the molar mass of NH3? Well, I'm going to need my periodic table for that. Let's see. So nitrogen weighs, I'm going to put that up here, 14.01. And then we have 3 hydrogens, each of which weigh 1.01. So what is that? Let's go to our calculator. So we have 14.01 plus 3 times 1.01. Okay, 17.04. So 17.04 grams of NH3 gas. All right, so that's going to get us to moles of NH3, right? Because grams of NH3 are going to cancel. So all we're left with is moles of NH3. Is that what we want? No. We want how much heat is being absorbed. So this now becomes similar to the last problem, right? Where we're going to want to figure out how much heat's getting absorbed. Well, we know that it's 92.4 kilojoules, but we're dealing with NH3 here. And so actually there's 2 moles of NH3. And this is where you're going to have to be applying Hess's law, because this is per mole, right? How many moles do we have? We've got 2 of them. And so how would we need to get this to 1 mole? Divide everything by 2. Now, I don't really need to do this. All I need to know is that I need to divide by 2, so that's what I'm doing. It's 92.4 divided by 2. Now, we can solve because we're looking for heat. And so we are pretty much done here because moles of NH3 are going to cancel out and we're just going to be left with kilojoules. So let's go to our calculator and see what this is going to be. We have 68 grams multiplied by 1 over 17.04 multiplied by 92.4 divided by 2. And that is 184.366. 184.366. Okay, I haven't really dealt with significant figures, right? How many sig figs are here? 3 sig figs. This is 4 sig figs. And this is 3 sig figs. So my answer can only have 3 sigs. So I have to round to that, and I'd be rounding down. So my final answer is 184. And what unit is left? Kilojoules. And what is happening? It's being absorbed. So 184 kilojoules of energy is being absorbed. So there we go. It's going to be your turn. Go ahead and try this out. Make sure you have a balanced equation and then use your stoichiometry. Pause the video and come back when you're done. See you soon. Okay, welcome back. I have the solution here for you. Let's go through it. So we knew that we had 1.44 times 10 to the 23 molecules of oxygen. So that's what we're going to start with. We need to, of course, get it to moles. So you're going to use Avogadro's number here to convert it to moles. That's going to give you this amount of moles. And you might have done it like we usually do in multiple steps, right? So we're going to use this answer now. And now we're going to multiply by a new ratio, which is for every 1105 kilojoules, we have 3 moles of O2. And that's going to give us negative 88.0771 kilojoules. We have 3 sig figs, so we need to round here. So this is actually going to be rounded up to 88.1 kilojoules. Now notice I had the negative sign in there. It's not going to impact my answer, right? But what I do know is that a negative amount of kilojoules means that it's being released, right? And in the problem, it also says how much is going to be released. So it's going to be very hard for you to get this wrong, right? But there you go. It's 88.1 kilojoules. Let's try one more. Go ahead and try this out. Make sure it's balanced, right? And then work your problem out. And when you're done, come back and check your answer. See you soon. Welcome back. Let's go through the solution. Okay, so we started off with 552.6 kilojoules of energy. So that's what we start off with. Now we need to get rid of the energy, and we know that it's 25 kilojoules, and we're converting into grams of carbon dioxide. We can't go straight to grams. We need to go to moles first. So we're going to look at the carbon dioxide in the problem, and there's 3 moles of it. So we're multiplying by 3 moles of carbon dioxide. Now we are going to change it from moles to grams using molar mass. So you find your molar mass of carbon dioxide, which I did down here, it's 44.01. And you're going to get this answer here. Now be careful about sig figs. You have how many sig figs going on? You have 4 sig figs here. You have 2 sig figs here. And so your answer should only have 2 sig figs. So 2,900 grams of CO2 being produced. And that's going to be it for today. There's nothing left for us to solve. Thanks for watching. See you in the next lesson. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.